In this video, I will explain how we can use naive Bayes algorithm for text classification. Let's first discuss the idea of text classification and relevance. Text classification is the process of assigning tags or categories to text based on its content. It is highly used in sentiment analysis, topic labeling, spam detection, and relevance. For example, whether the current email that we received should it be categorized as spam or not. Naive Bayes algorithm would help us achieve the results. Relevance is when search engine returns a set of documents relevant to user's query and the user manually marks the given results as relevant or not to the initial query. This causes the search engine to recompute based on the user's input, and further new results would hopefully have better recall. A good example of relevance is Rocio's algorithm. Let's consider a following example where we have three classes, China, UK, and Kenya, in a 2D space. Documents are either shown as circles, diamonds, or X. Boundaries are called decision boundaries to separate the three following classes. Let's consider a new document, which is star, to be assigned to a class. Now, based on its location, Rocio's classification computes the boundary to classify the unseen data. In this case, the document will be classified in class of China. Rocio's algorithm uses centroid to define the boundaries. Centroid C of a class is center of mass or vector average of its members. Rocio's algorithm can also be used for query expansion at search engines. For example, after searching herbs, users frequently search herb remedies. This gives the idea that herbal remedies is potential expansion of word herb. Another example where a user who searched for flower pick frequently clicks on a specific URL. Users searching for flower clip art also frequently click the same URL. Based on the results, flower clip art and flower pick are potential expansion of each other because user goes to the same URL after searching the following words. Naive Bayes algorithm is highly used for text classification. The idea is that given we have a document space X in which the documents are represented in this space and a fixed set of classes ranging from 1 to n, these classes are human defined for the needs of an application. For example, whether email is spam or not. In this case, we have two classes. And we also have a training set D of label documents, which is used to train our classification method. And each of these label documents belong to a specific class. Using a learning method, we wish to develop a classifier Y that maps the documents to a specific class. Let's take an example in which we have different classes. One class is named UK and another class is named China, and a third class is named poultry and another class is named coffee. A fifth class is named elections and another class is named sport. Now, given we have a new document which reads first private Chinese airline, we need to figure out where to classify this document. Based on the content of the new document and the probabilities of each document within each specific class, this document is classified in the class China. Naive Bayes classifier is basically a probabilistic classifier. Probability of document D being in class C is as follows. Given we have a document, to find the probability in which class it would be classified into is directly proportional to the prior probability of class C multiplied by the summation of all the documents, all the words in the document with the probability of that the term Tk occurs in the document of class C. The probability Tk given C is a measure of how much evident tk contributes that C is the correct class. In this case, nd is the total length of the documents that we have, and each of the token and it has several tokens, and each of the tokens ranges from 1 to k. Our goal in naive Bayes classification is to find the best class. Maximum a posteriori class method provides us the best class which is most likely to be considered for the specific word. The formula is to find out the probabilities for each of the classes based on the naive Bayes formula and find the maximum of all those probabilities, and the class with the highest probability would get the new word. Now, because we're multiplying very small probabilities, this can give us floating point underflow. This can be solved by taking the log of all the values. Since log of x multiplied by y is equal to log of x plus log of y, we can use log probabilities. And since log is a monotonic function, class with highest score doesn't change. Thus our math formula becomes as follows. For parameter estimation, we have probability of C and the probability of token given the class C from the trained data. Prior is the probability of dividing total number of docs in a class by the total number of docs. This gives us the probability that whether the current probability of a specific class. And the conditional probability is the probability of specific token given class C. This is the number of tokens T in training document from class C. Let's take an example where we have a document with contents of Beijing and Taipei join WTO. We divide all these words as separate and see whether they are classified as class China or not. So the probability that the document will be classified in China given the document is directly proportional to probability of China multiplied by the probability that Beijing exists in China multiplied by the probability of word and exists in China and multiplied by the probability of Taipei exists in China. Now all these words exist in the class of China except WTO. Now if WTO never occurred in the class China in the training set, then the probability would be 0. Thus we cannot assign this document into the class China. To avoid this issue, which is called the problem of zeros, we do the add 1 smoothing, where we add 1 to both of the numerator and denominator of the conditional probability. Naive Bayes algorithm estimates the parameters from the training corpus using add 1 smoothing. For a long document for each class, we compute the sum of the log of the prior and the logs of the conditional probabilities of the terms. We assign the document to the class with the highest score or the highest probability. Let's consider the pseudocode for the training of the naive Bayes algorithm. We extract all the words from the vocabulary, then we count all the docs, and for each word for each class in all the classes, we count the docs in that specific class and we find the prior probability, which is the probability of all the words in a specific class, all the docs in a specific class divided by all the docs. Now to test this algorithm, consider we are given a specific document D. We extract all the tokens from the document in W, and for each class we do a score of C and take a log of it, and for each token in words we do a score of that specific class multiplied by the log of the probability of that token, and we return the maximum of the probabilities. This would help us classify the given document into specific class with the highest probability. Let's consider an example to understand it in better. We have a training set of 4 documents in which 3 of them are classified in China and one of them is not classified in the class China. Now we have a new document which has the words Chinese, 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 Tokyo, and Japan. Now we want to figure out whether it is classified in class China or not. Based on our add 1 smoothing, we find the following formula. Apply the following formula to find out the probabilities, and based on the probabilities, we find that whether to classify the document in class China or not. Thus, classifier assigns, based on the results that we get, the classifier assigns the test document to China. The reason is that the classified decision has 3 occurrences of positive indicator of word Chinese in the document, which outweighs the occurrences of 2 negative words, Japan and Tokyo. The time complexity of naive Bayes algorithm is linear, and the training and testing of the documents is quite optimal. Thus, it can provide us real-time classification.